You are now watching the hand assembly of a Bentley V8 engine at the Crewe factory in England. Each engine takes approximately 30 hours to produce. One technician usually builds the whole engine from beginning to end, and their name is engraved on a plaque attached to the engine. Bentley officially stopped making the 6.75-liter V8 engine in June 2020 after 61 years of continuous use. The last engine was built at the Crewe factory and placed in a special Mulsanne 6.75 edition by Mulliner. This marked the end of both the Mulsanne model and the L-Series V8 engine. With a light press of the throttle, the system can deactivate 4 of the 8 cylinders, making the engine a more fuel-efficient 4-cylinder. Originally designed in 1959, the L-Series V8 was created in an era when emissions regulations didn't exist. Despite decades of updates, including the addition of fuel injection, catalytic converters, and other modern systems, by 2020, it could no longer be adapted to meet the increasingly strict EU 6 and upcoming Euro 7 emission standards. This engine is paired with an 8-speed automatic transmission that has been specially calibrated to deliver exceptionally smooth and effortless gear changes, enhancing the refined driving experience Bentley is known for. Bentley Dynamic Ride and Adaptive Air Suspension ensure balance and provide a strong foundation. While Bentley is widely recognized as a global leader in W12 engine production, it has never aimed to be the world's largest V8 manufacturer. Each engine took more than 25 hours to hand assemble at Bentley's Crewe facility, with the final product proudly bearing the signature of the technician who built it, a true mark of personal craftsmanship. Renowned for its exceptional low-end torque, the L-Series V8 delivered power with effortless smoothness, perfectly suited to the luxurious grand touring nature of Bentley vehicles. Some of the later versions of the engine delivered astonishing performance figures, producing over 1,100 Newton-meters of torque, approximately 800 pound-feet, providing effortless acceleration and a commanding driving feel. Though the engine kept its original 1959 block dimensions, it evolved with fuel injection, turbocharging, and modern emission controls, staying compliant while preserving its character. Bentley Mulsanne Speed was a twin-turbocharged powerhouse, producing 530 horsepower, making it one of the most powerful luxury sedan engines in the world at the time. The Bentley V8 became a symbol of British craftsmanship, standing apart as others shifted to mass-produced engines. Bentley marked the end of an era with a special final edition Mulsanne.
And lifting and walk.
The workers you're watching now were true professionals, guaranteeing the exceptional quality of every engine they built. At the end of the engine assembly process, a plaque reading engine number XX, hand built in Crewe, England, along with the name of the technician who built it, was carefully affixed to the engine, a proud signature of craftsmanship. Before leaving the production line, every V8 engine was dynamometer tested. This engine wasn't light, especially in the Bentley Mulsanne, where it contributed to a substantial curb weight of approximately 2,585 kilograms, which is 5,699 pounds, underlining the car's presence and road-commanding feel. Due to its sheer size and weight, the massive 6.75-liter V8 was lowered onto the chassis frame using an overhead crane, with skilled workers guiding it precisely into position by hand. What you're seeing now is the moment the engine and chassis are joined with the vehicle body, a key step in production known as the marriage, where mechanical and structural components come together as one. Factory workers typically operate in highly coordinated pairs or small teams, each person knowing their role and performing it with precision to maintain Bentley's exacting standards. From here, the assembly process will continue along the main production line, where interior finishes, electronics, and final touches will be added to complete the handcrafted Bentley. This is the fascinating story behind the creation of the massive and iconic W12 engines, a remarkable feat of engineering that once represented the pinnacle of automotive performance. Sadly, the era of these legendary power plants has come to an end, marking the close of a thrilling chapter in automotive history. Bentley W12 engine was produced at Bentley's Crewe factory in England from 2002 until 2024. It's hand-built using hundreds of precision-engineered components, showcasing exceptional craftsmanship and exclusive design. Each one of these remarkable engines took roughly 8 hours to assemble entirely by hand. The engine alone came with a hefty price tag of around £200,000, approximately 240,000 euros. After 2024, Bentley transitioned fully to hybrid powertrains, phasing out the legendary W12 across all its models. Bentley cars are most popular in the United States, which has consistently been Bentley's largest single market. Wealthy buyers in cities like Los Angeles, Miami, and New York are major consumers of Bentley's luxury models. What you're seeing now is the careful manual installation of the crankshaft, soon to be followed by the pistons in the heart of the W12 engine. These magnificent engines were installed in some of Bentley's most prestigious models, including the Bater, Continental GT, Bentayga, Flying Spur, and bespoke Mulliner editions. Before leaving the factory, each engine undergoes over an hour of intensive testing, including leak checks, cold starts, and initial fire-up procedures to ensure flawless performance. In this British factory, skilled workers rely on overhead cranes to safely and precisely maneuver the heavy engine components during the hand assembly process. Renowned for its buttery smooth torque delivery, distinctively rich engine note, and exceptional performance, the W12 set benchmarks for refinement and speed in the luxury segment. Its innovative W layout design combines two narrow-angle V6 engines on a single crankshaft, delivering 12-cylinder smoothness in a more compact and lighter configuration than a traditional V12. Over a remarkable 22-year production run, more than 105,000 W12 engines were meticulously hand-built at Bentley's iconic Crewe facility. At the heart of each engine lies the crankshaft, an extraordinarily complex and robust component, engineered to withstand immense levels of torque with absolute precision. The redesigned W12 TSI, introduced in 2015, marked a significant leap forward in engine technology. it became the most advanced 12-cylinder engine in the world, featuring dual fuel injection systems, twin-scroll turbochargers, cylinder deactivation, and split cooling circuits to maximize efficiency and performance. This is essential viewing for anyone passionate about real-world engineering and high-performance automotive innovation. After final assembly, every W12 engine was subjected to a rigorous and precisely controlled testing cycle. This included a series of evaluations such as leak detection, cold cranking, hot running, and detailed assessments of sound and vibration characteristics, all conducted on a state-of-the-art test bench. Each test cycle took over an hour to complete, ensuring every engine met Bentley's exacting standards. Some internal components were engineered to tolerances tighter than 0.01 millimeters, a level of precision surpassing even many Formula One engine parts. The pistons and crankshaft in the W12 engine are balanced with such extraordinary precision that engine vibration is virtually imperceptible, whether at idle or under high-speed load. This smoothness is a hallmark of Bentley's commitment to refinement and engineering excellence. Each engine was hand-assembled by a dedicated team of expert technicians who were given the rare honor of signing or tagging the engine upon completion. This personal touch means that every W12 produced carries not just mechanical excellence, but also the pride and identity of the skilled individuals who built it. Although the W12 was originally a concept developed within the Volkswagen Group, every Bentley W12 engine, from the very first unit in 2002 to the final build in 2024, was exclusively manufactured at Bentley's historic Crewe facility in the United Kingdom. The same base W12 design also powered a select number of flagship models from other VW Group brands, such as the Volkswagen Phaeton and Audi A8. However, it was at Bentley where the engine reached its most advanced and luxurious form, continually refined for greater performance, smoothness, and exclusivity. The final production run of the W12 was strictly limited to just 18 units. These special editions received bespoke calibration and hand-tuned assembly, ensuring peak balance, efficiency, and power, a fitting farewell to one of the most iconic 12-cylinder engines in automotive history. Bentley officially concluded W12 engine production in 2024 as part of its forward-looking Beyond 100 strategy, a bold commitment to shift entirely toward hybrid and fully electric drivetrains in the coming years. And if you're anything like me, watching this moment unfold might stir up some emotion. But don't worry, W12-powered Bentleys are still out there. You can still purchase one on the pre-owned market and experience the thrill of that engine for yourself. Bentley's legendary Crewe facility, located on Pims Lane, is home to approximately 4,000 employees. Within the main assembly hall, a single 8-hour shift is operated by around 700 highly skilled workers who focus specifically on body construction and final vehicle assembly, combining craftsmanship, precision, and tradition in every detail. Each W12 engine that left this factory wasn't just a power plant, it was a pinnacle of human ingenuity, precision engineering, and the relentless pursuit of automotive perfection. Before any W12 engine made its way to the main vehicle assembly line, it had to successfully complete a series of rigorous tests to ensure optimal performance, durability, and reliability. In April 2024, a historic milestone was reached. The final W12 engine was hand-assembled at Bentley's Crewe facility. This last batch of engines was reserved for the exclusive Bentley batter, each producing a remarkable 750 horsepower in its final, most powerful configuration. This is the assembly of four-cylinder engines in Audi Hungary, Győr plant. Audi Hungary is recognized globally for its high-volume and high-quality engine production. It has produced over 40 million engines since its founding. The plant serves both Audi and other brands of the Volkswagen Group, including Volkswagen, Seat, Skoda, and even Porsche in some cases. These engines typically range from 1.4 to 2.0 liters in displacement, including some of the most widely used models, such as the 1.5 TFSI and 2.0 TFSI, known for their balance of performance and efficiency. These employees in red work overalls carefully assemble the entire engine by hand. Audi Hungary is responsible for the production of both petrol and diesel four-cylinder engines, supplying powertrains for a wide range of Audi and Volkswagen Group vehicles. The engine blocks, made from lightweight aluminum, are either cast on-site at the facility or delivered from external foundries. Once on-site, they undergo precision machining using advanced CNC equipment to meet exacting tolerances. Audi Hungary employs highly automated and digitally integrated assembly lines. These systems include torque-controlled fastening tools and computer-aided quality inspections at every stage to ensure accuracy and consistency. Before an engine leaves the plant, it must pass a comprehensive battery of tests designed to verify performance, emissions compliance, and long-term durability, ensuring each power unit meets the high standards expected of the Audi brand. Audi Hungary has been capable of producing several thousand engines per day at full capacity. The Győr site is one of the largest engine manufacturing facilities in the world and employs approximately 11,900 people, playing a central role in the region's economy and Audi's global supply chain. Engines produced at the Győr facility are shipped worldwide, supplying Audi and Volkswagen assembly plants across multiple continents. Once assembled, engines are stored and transported through a meticulously coordinated logistics network that combines both rail and road systems, ensuring efficient and timely delivery, particularly to key manufacturing hubs in Germany. While Audi Hungary is steadily shifting more of its production capacity toward electric drive units in alignment with the industry's transition to e-mobility, four-cylinder internal combustion engines remain a vital part of the operation during this transitional phase. Four-cylinder engines continue to represent a substantial share of Audi Hungary's total engine output, owing to their widespread application in compact and mid-size vehicles across the Audi and Volkswagen Group portfolio. Their efficiency, performance, and versatility make them a mainstay in global automotive production. Watch closely as this skilled factory worker hand assembles a powerful AMG engine, a rare glimpse into the heart of high-performance craftsmanship. This is the manufacturing process of the Mercedes-AMG M139 engine, a 2.0-liter powerhouse producing an incredible 421 horsepower. The M139 isn't just any engine, it's a true masterpiece of modern performance engineering, combining cutting-edge technology with handcrafted precision. It currently holds the title of the world's most powerful series production 2.0-liter, 4-cylinder turbocharged engine, setting new benchmarks in its class. At the core of AMG's philosophy is the principle of one man, one engine. That means each engine is assembled entirely by hand at the AMG engine plant in Affalterbach, Germany. From start to finish, a single AMG technician is responsible for the entire build, ensuring unmatched attention to detail and quality. As a personal signature of their work, the technician's name is proudly displayed on a plaque mounted atop the engine, symbolizing pride, responsibility, and the human touch behind every AMG power plant. Manufactured at the AMG engine manufacturer in Affalterbach. The AMG engine facility is designed in accordance with Advanced Industry 4.0 principles, incorporating smart manufacturing techniques, digital assistance systems, and modular assembly stations to maximize flexibility and precision throughout the production process. Precision torque tools and integrated sensors ensure that every fastener is tightened to exact specifications. Each completed engine is subjected to a full series of tests on sophisticated dynamometers, including leak detection, oil pressure analysis, and controlled performance runs under varying loads. One of the key engineering innovations of the M139 engine is its reverse flow layout. The turbocharger and exhaust manifold are positioned at the rear of the engine, closer to the firewall, while the intake system is placed at the front. Internally, the engine is built for strength and durability. The twin-scroll turbocharger features advanced roller bearings to minimize friction, an electronically controlled wastegate for precise boost management, and can reach turbine speeds of up to 169,000 revolutions per minute. This strong and experienced technician is Michael Mittler, one of the skilled hands behind AMG's high-performance engines. Each year, approximately 20,000 engines were hand-assembled at the AMG engine facility, with a dedicated team of around 1,000 employees working across all engine lines, not just the M139. The M139 engine itself is a showcase of thermal and mechanical engineering. It features two separate cooling circuits, one for the cylinder head and another for the crankcase, allowing for more precise temperature control across different parts of the engine. Inside the cylinders, the walls are coated with Mercedes-AMG's proprietary nanoslide technology. This ultra-thin coating reduces internal friction, increases wear resistance, and helps manage heat more effectively, all crucial for longevity and high revving performance. With a specific output of 210.5 horsepower per liter, the M139 ranks among the most powerful production car engines in automotive history on a per-liter basis. At the heart of this process is AMG's renowned one-man, one-engine philosophy, meaning each engine is assembled start to finish by a single, highly trained technician. That technician, like Michael Middler, is personally responsible for every component and every step of the build, not just one task on a conveyor, but the full assembly. The assembly process relies on torque-controlled, digitally monitored wrenches to ensure every bolt is tightened with absolute precision. These smart tools help maintain consistency while allowing the technician full control over the build. Each technician is personally responsible for the engine they assemble, from the first component to the final inspection. This method instills a deep sense of accountability and pride in their work, which Mercedes-AMG believes directly contributes to the engine's long-term reliability and high-performance standards. Upon completion, every engine receives a hand-signed metal plaque bearing the technician's name. This badge of craftsmanship is mounted prominently on the top of the engine cover, a visible and enduring symbol of precision, pride, and the human touch behind every AMG power unit. Unlike conventional mass production methods, this approach allows for personalized attention to every detail. Human craftsmanship ensures that each engine is carefully monitored for quality at every stage, reducing errors and maintaining consistently high standards. This hands-on philosophy not only preserves Mercedes-AMG's rich brand heritage, rooted in motorsport and high-performance engineering, but also creates a more emotional connection with the customer. The result is an engine that feels not just engineered, but truly crafted. Pride and accountability are the driving forces motivating technicians to deliver nothing short of perfection in every engine they assemble. On average, the entire assembly process takes between 3.5 to 4 hours. This covers everything from careful component preparation, full manual assembly, precise torque verification, to detailed digital logging of each build step, followed by thorough leak testing and final inspection. Technicians typically build just 1 or 2 engines per day, depending on the complexity of the model. Although the assembly process is time-intensive, AMG consciously chooses to avoid automation, preferring the human touch to guarantee quality and craftsmanship. After finishing assembly, the technician, like Michael, personally tests the engine he has just built to ensure it meets exacting standards. This factory alone produces about 140 M139 engines every day. Affalterbach is the historic heart of AMG, where the company evolved from a small two-man tuning shop in 1967 into a globally recognized performance division. Mercedes-AMG officially became a full part of Daimler-Benz in 1999, but Affalterbach remains its spiritual and operational home. Each engine builder at the plant undergoes specialized training focused exclusively on engine assembly, dedicating their expertise to this critical task. The AMG engine plant in Affalterbach employs roughly 200 to 300 people, including engine builders, support staff, and management personnel. Among these, around 120 engine builders are fully qualified to sign their own engines, an honor earned through decades of mechatronics training and practical experience. About 60 of these builders focus on standard AMG engines, which are marked with silver plaques. An elite group of approximately 14 to 16 Black Series builders, distinguished by dark gray or black plaques, are certified to assemble the highest performance limited-run engines. The signature plaque each builder affixes to their engine isn't just symbolic. It represents personal accountability, the highest quality standards, and true mastery of their craft. Once completed, the engines are transported to storage and delivered to the main assembly line at precisely the right time, where they are installed into their designated chassis. While Bentley is a relatively exclusive brand compared to mass-market luxury marques like BMW or Mercedes-Benz, it consistently attracts attention for its high-end models such as the Continental GT, Bentayga SUV, and Flying Spur sedan. These vehicles appeal to buyers seeking a combination of prestige, comfort, and performance. In recent years, Bentley's popularity in the U.S. has grown steadily, driven by increasing demand for luxury SUVs like the Bentayga, which broadens the brand's appeal beyond traditional grand tourers. Additionally, Bentley's focus on customization and craftsmanship resonates well with American buyers who want a unique, personalized vehicle. In your opinion, which engine stands as the absolute pinnacle of automotive engineering? Please share your thoughts and reasoning in the comments section below. Let's start a passionate discussion about the engines that have truly shaped the world of automobiles. Now we head to the very heart of Germany, the historic Porsche factory in Zuffenhausen, Stuttgart. Here, highly skilled German technicians are assembling a high-performance engine destined for the latest generation of the iconic Porsche 911. Precision, passion, and tradition are woven into every step of the process. The Zuffenhausen site houses two state-of-the-art engine production facilities. One focused on internal combustion engines, including the legendary flat-six and powerful V8 units, and another dedicated to the production of electric motors for the Porsche Taycan and upcoming electric Macan. Zuffenhausen remains the exclusive site for the assembly of all Porsche 911 engines, preserving a legacy of engineering excellence that continues to define the brand. This includes all flat-six engines, whether naturally aspirated or turbocharged, Carrera, Turbo, and GTS. Zuffenhausen is one of the few automotive plants in the world where the engine and the vehicle are built in the same location, a unique feature that enhances quality control and precision integration. The engine blocks and cylinder heads begin as lightweight aluminum castings, which are then meticulously machined using high-precision CNC equipment to achieve exact geometries and surface finishes required for high-performance operation. Each machined component undergoes detailed inspection using advanced measurement technologies, including laser scanning and high-resolution camera-based systems. These systems ensure that every surface, bore, and critical dimension falls within strict tolerance limits, guaranteeing reliability and consistency throughout the engine's life cycle. Engine assembly takes place in climate-controlled cleanrooms designed to eliminate dust, airborne particles, and temperature fluctuations that could affect precision tolerances. Technicians wear anti-static uniforms, and all components are handled with gloves to avoid contamination from skin oils or debris, ensuring the highest standards of cleanliness and care. While much of the process is supported by advanced automation, the most critical assembly stages are performed by hand, carried out by highly trained specialists with years of experience. Porsche employs wireless torque tools throughout the assembly line to guarantee that every bolt is tightened to exact specifications. The data from each fastening operation is digitally recorded and stored for full traceability and quality assurance. Once assembly is complete, each engine is mounted on a test bench for a cold and hot run-in phase. For select high-performance engines, particularly GT variants, an additional phase of individual dynamic testing is performed under load conditions to validate performance at the limits. Although automation enhances efficiency and consistency, the guiding principle behind the entire process remains rooted in Porsche's philosophy: precision by hand.